What are the possible last two digits of the number plate of a car? Well, it could be the number 00 or 01 or 02 and so on up to 99. So there are 100 possible last two digits. Here in these questions, we have 10 cars altogether, so there will be 10 number plates. Let us denote this car by C1, C2, up to C10. What is the sample space that we're interested in? Well, we want to know whether the last two digits on the number plates of these cars are the same or distinct. So each outcome of this random experiment can be represented by a tentuple, here denoted by x1, x2, and so on, up to x10, where each entry is the last two digits on the number plate of the corresponding car. So for example, x1 is the last two digits for the number plate on car 1, and so on. So each xi comes from the set containing all the possible last two digits. If S denote the sample space, then the size of the sample space is going to be 100 times 100 and so on. There will be 10 of them altogether, so this is 100 to the 10. Now suppose A is the event that all the 10 cars have different last two digits. We want to find the number of elements in A. Each element in A can be represented by the tentuple x1, x2, and so on up to x10, where we want all the xi to be distinct. We can count the number of elements in A by first counting the possibilities for xi. Before choosing the other entries, we have 100 choices for x1. Sorry, we can first count the number of x1. So 100 is the number of choices for x1 before we count the other entries. After x1 is chosen, we want x2 to be different from x1, so there are 99 ways to choose x2. Having chosen x1 and x2, the number of ways to choose x3 so that it is different from x1 and x2 is 98, and so on. So the last number will be 91, because all of them altogether there will be 10 numbers in this expression, in this product. So this will give us 100 P10. Or another way of writing this is 100 factorial over 90 factorial. Now, what can we say about the complement of A? Well, this is the event such that there will be at least two cars having the same last two digits. So the events that there exist at least two cars with the same last two digits. Therefore, the probability of the complement of A is 1 minus the probability of A. Since we have worked out the size of A previously, so this will become 1 minus the size of A divided by the size of the sample space. This is 1 minus 100 factorial over 90 factorial divided by 100 to the 10. This number is approximately 0.37. We can now describe the game that we play with our friend in the question. Let X be the number of dollars that we receive from the game. There are two possibilities. If at least 2 of the 10 cars that we see on the road have the same number formed from the last 2 digits, then we receive $1. This is the case when the complement of A occurs. So in the first case, we'll receive $1. Otherwise, we will pay him $1. So X will be -1 because X is always the number of dollars that we receive. So we write down here is the dollars, the number of dollars that we receive in this game. In order to determine whether we will accept the bet or accept to play the game, let us try to first find out the expectation of this random variable x. So we want to know what is the average number of dollars that we'll receive from the game. Since there are two cases, in the first case when the complement of A occurs, we'll receive $1. That happens with probability of given by the event's A complement. Otherwise, we will get -$1. That happened if the complement of A occurs, which means if A occurs. Previously, we have determined the probability for the complement of A, which turns out to be 0.37. Therefore, 1 minus 0.37 will be the probability of A. That will give us 0.63, right, which is 1 minus 0.37. The final answer is minus 0.27, which says that on average we will lose about 26 cents. So the conclusion is we will not bet on the offer. So we will not bet in this case. What happens now if our friend offers to pay $2 instead of $1? So suppose we have $2 in the first case instead of 1. Do we still want to accept or reject the bet in this case? Well, we can calculate the expectation of x again. This will be given by 2 times the probability of the complement. Since the payout in the other case does not change, we still have -1 times the probability of A. So as before, this is 0.37, and we have minus 1 times 0.63. The final answer this time is actually equal to 0.11. Meaning on average we will receive about 11 cents from the game. Well, since the payout is positive, we would bet on the game. We would bet, or we would accept the bet. Right? The bet.